Hello everyone and welcome back to another video. In this video we will go through the main blocks of the code and go through the code in a little bit more detail. I recommend you put up the code next to you. Maybe if you have another monitor, put it on to the next monitor and just follow along. So let's get started. The main blocks of the code are firstly defining the console keys, then choosing the right frequency, setting the device class, joining the network, and if all that is successful we should see some data uplinks. So let's get through it. So the first thing you do is define the console keys like we did in the last episode, and also defining your region. Then we have this payload. In this payload we basically append all the data that we want to send, and then we send this whole variable, the payload variable, over the network, and then we later decode it. You might have noticed this uint8_t. This basically means unsigned integer with 8 bits, so 1 byte. Unsigned means that it's a positive value, so it is a negative. Integer is just an integer, and 8 bits is 1 byte. So if you have a range unsigned, that means we have a total range of 0 to 255. If it was signed, so we have a negative value, then it would have been negative 128 to 127. This is pretty important, and in the next episode we will dive a little bit deeper into that topic. So then we start with serial.begin. This is a standard Arduino function, and it basically just starts the serial port with a baud rate of that value. Then we define the console keys. This is just copy paste, you don't need to change any of this. And then we set the band. So this is pretty important. Like we did in the first episode, you have to look up the region, and then you have to define that into the RUI tree code. You can see all the regions you can choose from with the corresponding frequency with the Helium. And there are 12 different regions you can choose from at the moment. Then we have the classes. There are 3 different classes possible: class A, B, and C. Class A basically means you can uplink at any time, but you can only downlink at 2 short periods after an uplink. Class B is pretty much the same as Class A, but it has additional ping periods for downlinks. And then Class C is a completely different beast. You can also uplink at any time, but the downlink radio always stays open, so you can always downlink at the device. Class C is not supported by Helium yet, but it will come in approximately Q1 2023. Then we set the network join mode. You have 2 different options, namely OTAA and APB, over the air activation or activation by personalization. The best one is OTAA. It's the most secure one, and unless you have a very specific reason to use APB, you should always use OTAA. If you want to learn more, I recommend you click this icon, and then it explains it in great detail what the difference is. Then we join a network. This function just initiates the join process, and it will return a true or a false if it is successful or not. If it is not successful, you can call this multiple times until you have joined the network. And then we prepare the payload. So we first create an unsigned integer, so an 8 bits length variable. Then we append the payload with the data. In this case is 2. So we just append 2 to the payload variable, and then the payload variable is later sent. So here we send the data. So we use this function api.lorawan.send length payload port confirm and retry. Length is basically the length of the payload. The payload is the data to be sent. The f port is basically that defines basically a port, and that can later be used when decoding the payload. This can be handy when you're trying to send different types of data at different times. Then it might be useful to use different ports for that. Then confirm, which basically means if the gateway has received your uplink, it will send a downlink message, and that will tell the device, okay, I have successfully sent the message. And then retry. If sending failed, it will try to resend a message or an uplink. And then if this is successful, it will return true. Then lastly, we sleep the API, so the CPU and the LoRa module. This is defined in milliseconds, and can be used as a timer or a delay between uplinks. This is very quickly what you need to know. I recommend you go to the official RUI 3 documentation, because everything there is explained in great detail how to use different functions and what the parameters are and etc. There is even example code which makes it extremely easy to understand. In the next episode we will be sending bigger data payloads through the network, and then we will use some different solutions to do so. So see you then.